Hello and welcome to this new video of Randomantic. Now we're gonna start talking about physics in a series of videos. So I don't know how many videos I'll do about this topic, but it will be the main focus of the channel for a good amount of time since now. So in terms of physics, we can really talk about a lot of different things. What's the goal of this kind of podcast? So it is to share my opinion, of course, but also to make it a bit easier to understand as is if someone was actually talking to you, so it will be easier to understand, as well as um, some things that are not really defined, that we don't really know the answer, so we can still discuss about it. So why is it? Okay, maybe when you think about physics, you would say, well, what's that physics focus? What is the main focus of physics as a subject, as a discipline? Well, physics is mainly kind of the part of science that studies how stuff interacts kind of physical systems like matter and energy, if you want to talk in terms of that. But if you want to be more kind of precise and less, maybe to be a bit more precise or real, you want to talk about how the universe works in terms of how its parts behave or interact with one another. Okay, so if we read a bit about physics, what I can read on the internet um, will be that physics is not something that we are seeing a lot of advances from in terms of huge breakthroughs in terms of how the universe works, of our explanation to very important unanswered questions that we still have. Okay, so what I want to talk a bit about is the concept of gravity. So, what is gravity? Well, in simple terms, gravity is just um, a behavior, maybe the most important or fundamental behavior of stuff. What do I mean when I say stuff? Well, there's really I'm trying to be kind of precise here. I don't want to use words like energy or matter because we don't know exactly what that means. Because this today science is simply doesn't understand it fully. So I want to call it just stuff. The stuff that exists, anything that exists is a part of the universe. Universe meaning everything that exists. So, personally, I don't like the idea of infinite real phenomenon. In my opinion, everything that exists, everything that is real, it's finite. I mean, you can have infinite numbers if you keep writing, but a number is not something physical. You cannot touch a number. But in terms of physical stuff like the universe, like stuff, you know, it has to be limited. It has it cannot be infinite. It has to be finite because it simply doesn't make sense in terms of real world for something to be infinite. Nothing that exists, nothing that's made of stuff is infinite. Everything that's made of stuff is finite. Why do you want to clarify that, even though I have kind of no proof of that? Because for me, and for any basic understanding of the universe, in my opinion, infinity is not useful in real terms. Um, yeah. So, what I'm saying is that it's better to think about the universe as a finite thing, a finite entity, because only then we can figure exactly out and study it more. Otherwise, we won't be able to dig uh, deep enough to understand how it works. Okay, so we start with the assumption with the assumption that the universe is finite, and we define universe as all the stuff. That's it, all stuff, and it's finite. And when I mean stuff, I'm saying just one thing. I'm not differentiating between light and matter, or energy and matter and dark matter. I'm not differentiating them. I'm I'm calling matter, matter, dark energy, whatever else, just energy. All of that I call just stuff. Why do I call stuff? Because I believe all of them are different flavors of the same thing, which we don't have a word for. That's why I just call it stuff. Yeah. Yes, what I'm saying is that everything is the same thing, is the same material, but in different form. So light is the same as particles, as we call it, as protons, but in a different shape. That's why electrons can absorb light. I mean, everything is the same. It's just stuff, as well as a black hole is the same as regular matter, but just denser. Is a different flavor of the same basic ingredient, same basic and only ingredient that exists that I call stuff. The same with energy, same with dark matter, the same with all of that. So I don't know what dark matter and dark energy is, but of course I for almost everything I have something that I think it is, and of course I want to share it with you. So dark matter and dark energy for me are just regular matter and regular energy that are a lot bigger, if you want to call that way, a lot bigger than a lot more far away than current matter and energy. This sounds stupid, and maybe the content I make is not very engaging, in contrast to the rest of the content that is available about physics on the internet. But the content I make, like this video and the next videos, will be this content is different and is a fresh view of me. At least if it has errors, it has only my errors. It doesn't have errors of lots of people. because I want to try to come out with ideas of my own. Uh, right? So, let me explain you a bit more what is dark energy and dark matter and why I'm talking about it while I was talking about gravity. Well, I thought I told you that gravity is the most important thing, but actually that's not true. Gravity is not only the most important thing, it is actually the only thing, the only behavior, the only property of stuff. But we also see different properties like electromagnetism, nuclear force, and all of that. But again, those are the same as gravity, but in different flavors. Again, so what are you trying to say, Randomantic? Well, I'm trying to say that we have only one thing, one ingredient, which of course can have different shapes like energy, matter, dark matter. And we also have one behavior that can also have different shapes, uh, which is gravity, which can have shapes like charge, electromagnetism, quantum gravity, nuclear forces, regular gravity, right? So what I'm saying here is we only have one thing, stuff, and that thing only has one behavior, which is what we see with gravity. If you want to understand it better, that is stuff that wants to be kind of attract other stuff. But then when you have a lot of things and systems that evolve over time, you can arrange that in terms of different objects, densities, distances between them, sizes, and you when you arrange them in those different things, different ways, we can observe the patterns or the behavior. That's a dog, by the way. I'm scared about it. It's neighbor's dog. I don't know what to do about it, but I just. Well, let's continue. So, the universe is just one thing I call stuff. With stuff, I mean everything that is a thing. Energy, matter, dark energy, dark matter. Um, yeah. And all that stuff thing, the only thing that exists, only has one property. That property is is changing the density of the whole stuff that it's finite. We call universe. What do you mean with this? So changing the density. If we have something finite and changes its density, it has to have a sort of infinite loop in which the density of the system increases and the density of the system decreases. Right? So, the density of a system is really all we care about. But we see it as different behaviors if we compare with how the moon orbits around the earth and how the electrons orbit a proton or the nucleus of an atom, then that's actually pretty much the same as any other interaction we may think about, like why a light bulb shines. But the changes in density flavors are wild. That's why we perceive them as different forces like electromagnetism, gravity, nuclear force, and whatever else we can figure out. And we're not limited to, well, in practice we may be, and in locality, but if we go maybe very far away from here, we may have a lot of new different what we call properties, which are just different flavors of the same property, which is changing density. Um, I don't know if someone will understand what I'm trying to say. I don't know when will someone understand what I'm trying to say. Why I'm recording this? Well, just in case it is useful for someone. Um, I may die. I may forget about it. I may have some sort of a mental illness in which I can forget. I don't know. That's why I'm recording this, because I think it's the most important thing that I have figured out. I'm not native English speaker, so sorry if I don't speak right or correctly. But the message I'm trying to tell you is that we have to simplify our view, and we have to have a sort of one fits all philosophy in order to understand how stuff works. That's my approach. That's the only approach I think it's valid. Um, Let me go again. Why? Well, maybe because um, the first time I didn't explain it correctly. Maybe you want to try to rephrase it or say it in a different way. Okay. I wanted to know how the universe works. I was not satisfied on how the conventional science or knowledge in books and the internet explained how the universe works. I was not satisfied with that explanation. So I wanted to do it myself. Even if it's wrong, I feel a lot better because it was something that was created by me. I don't know if someone has thought about this before me, but I have no way of knowing it, right? Okay, at least it's not in the public domain if someone has thought this before me. And I figured this out in 2015, kind of maybe October of 2015. I was 18 years old. I needed to have an understanding of how the universe works. That was just my top priority. So one day I started thinking about it. It took me kind of 2 hours of silence and thinking to say, well, and the first, when you think you want your brain, my brain, tags stuff with sentences. One of the first sentences that had come to my mind was, all is one. So this sort of unification thing. Everything is only one thing, actually. It's just one thing with a very exotic shape. That's why we perceive as different objects, but it's just one thing. It's just healthier to see it as just one finite thing, stuff. And all it's really about the shape of it, and then how it moves, how it evolves, how the shape changes. So I'm telling you that everything is something, is one thing, and everything that it does is change its shape. So far, I think I know how that shape changes, kind of what fundamental behavior it has. And as far as I can tell, it what it does is simply change its density. So what I'm telling you is that the universe has one behavior. Why has that behavior? It's just its behavior, the only behavior. And that's changing its density, changing its shape. Imagine my hand was the universe. And its behavior is, so let's say my hand weight, imagine my hand is floating and it's just this. So let's say it weighs 2 pounds, right? It has this amount of stuff. It's limited, it's finite, and it's constant. I actually agree with that thing of thermodynamics that says nothing can be created nor destroyed. That's right. Okay, so that's the universe. And all it does, its shape is constant, its size is constant. All it does is change, I mean, its shape changes, but its size is constant. All it does is change in its shape. And so far, I can describe that shape changing as density increasing, like compressed, and then decreasing, and then again and again and again. And my friends, in my view, that's everything and the only thing that the universe does. So, the universe is just one thing I call stuff. And all it does is change its density. Now, we can classify everything in terms of its density and organization of its density. So light has less density than a black hole. Depending on the density of something and its arrangement in terms of something else, it can attract that, like gravity does, like a black hole attracts light. Yes, so again, I'm not good at explaining stuff. I'll try to be better. I'll try to make more videos about this topic. But I'm trying to say is everything is very simple. Think of the universe as just one thing, and think of it as just one behavior change in its shape. And how it changes its shape is just increasing and decreasing its density. So that sentence I just said is everything you have to know about the universe. Everything else just depends on how of the actual shape. So imagine you have a simulation with an equation as a rule. The equation rule of that simulation, of the universe simulation, is we have only one thing. That thing changes its density depending on how it is organized. Sometimes if you fill it with random values, sometimes the density will change faster, sometimes it will change slower, sometimes you will have a shape in which everything is condensed into one thing, and sometimes you have a shape in which you have something different, like some things are condensed and some things are not, like black holes and stars and whatever, right? So following this thought, I was going to explain what dark matter and dark energy is, which accounts for 85% of the movement or the visible movement of stuff. So it's just regular stuff that it's outside the measurement or our horizon. It could be something a lot denser than black holes, but it doesn't have to. It has it has to be stuff. The problem is, I will give you an example. I am not moving with respect to the camera or the earth for that matter, but the earth is moving with respect to the sun. What's causing that motion? Well, the gravitational movement of the sun. The sun being something a lot larger than the earth, so the earth can be moved by the sun. Now, why the sun moves? Because it's orbiting a galaxy, which is an even larger object. Why galaxy moves? Again, because it is orbiting an even larger object, which we are not able to see, and we call it dark. But if we keep going this way, because we don't know how big the universe is, but it is finite, as I told you. If we keep going, we will reach a limit in which we won't be able to still say that something that moves is orbiting something else. Why? Well, because the inability for something to move away from something else, like why I'm not flying, is because Earth has mass and gravity, and Earth is again moving around sun, and the sun is moving around something else. But if we go and zoom out to a larger object, a very large object, we may find something different, in which we can maybe say, I don't know a number, but let's just for picturing it, a tenth. So if we zoom out until we reach an object size of a tenth or a quarter or whatever of the whole universe, what will happen there? How will that object behave? Okay? So that object may move somewhere, not because somewhere something else is attracting it, but maybe because it was kind of result of an explosion. Yes. So we can either see the cosmical expansion as an explosion, and the 85% energy that we don't see, maybe because there's no matter that slows that down. That's why it's expanding so fast. But on the other hand, it could be that it's matter or stuff outside our observable universe that is attracting everything else in different shapes. Like think that of these like the observable universe, right? Of this sphere. So think of this as the observable universe, and we see stuff moving away from each other. Okay, objects. Why that happens may be because of an explosion that's moving away, and there's nothing to slow it down because there's no kind of something to slow it down. But we can also have the same behavior when we have something like a larger sphere that is beyond our observable universe, that it's attracting every point in a sort of vector to it. So imagine a sphere right here and it's attracting it. That's why we see expansion. So two possible options really if you follow the simplicity of the philosophy of seeing the universe as I told you, which is change in density. So, but then sometime the whole thing, the whole universe will go and reach a sort of a high density state in which, like stars, like supernova, it's not sustainable and will explode. And it's a cycle and will go it again. So this was very personal ideas, which may be hard to digest for almost everyone. But I think I need to do this. Maybe one day people will understand what I'm trying to say. And if you think in this way, you can explain a lot of things. So if you keep thinking this way and you want to explain the measurement problem of quantum physics, you would say your measurement actually is limited because the smallest an object is, the most influenced it is by everything else in the universe. In finite universe, yeah, not really, but yeah, in this case of a finite universe, the larger you are, the smaller the rest of the universe is. So the larger you are, the less the influence, fewer influence will have the universe on you. On the other hand, the smaller you are, the more influence will have the rest of the universe on you. And this is again, in terms of particle and wave, the largest you are, the more particle-like you are. The smallest you are, the more wave-like you are, because you are perturbed by the rest of the universe more easily. Again, I'm not a native English speaker, but English is the best language for this, so I'm trying. Okay. So that's basically what I wanted to tell you. And we can explain everything with this. We can go on and on. Why charges exist? Well, as my understanding thought experiments have done, when we have a very sort of, I don't want to call it the Big Bang, but it is a Big Bang, I wanted to call it. And when it happened, let's say, I'm not sure if it was of these Big Bang, of another Big Bang when this happened, but it was from a Big Bang, right? So when a Big Bang that emerged, that gave rise to these properties. So as I see it, it may have these properties. Just my imagination, but we could have a slightly different way. It could have occurred in a slightly different way. But my imagination is just simple imagination. If you have a lot of density here, and it will explode because exactly like a supernova, but in terms of larger size, maybe the universe, maybe a third of the universe, but maybe a tenth, but this is a very large size, large enough to only give away, for example, photons. Like, a black hole give Hawking radiation. Let's imagine for a moment that this Big Bang, maybe it's the Big Bang of 90% of everything or 10% of everything, but it's a large part of the whole thing. Okay, I don't know how big should it be to produce what I'm about to tell you. Okay, it has to be big, very big. How big? I don't know. When it explodes, like exactly like supernova, this time imagine all it gives away. It's transformed into an explosion of only photons, light. But those photons doesn't behave like they do now. They are still photons, but the behavior of photons now exists because of the current whole organization of the whole shape of the stuff. But in that shape, photons will have gravity to attract only other photons. It's a thought experiment. I just want to follow me on the thought, not on the actual things that I'm saying. So imagine the density, it explodes into photons, every direction, regular explosion, everything is transformed 100% to photons. Then those photons, which, because everything else is a photon, it's easy for them to form into groups. I don't know how many, but it's easy for them because there's nothing that is attracting them outside this. It's easy, even though it's an explosion, there's no attraction of gravity for those photons. So they are able to combine and form denser. So denser is the key because density is the only behavior. Denser objects like electrons. But now, when we have a lot of electrons, the universe is a different place. It's now harder for photons to combine and form more electrons, so they got absorbed by the already existing electrons. But again, everything is just electrons and some photons, but majority of the market share is electrons. And again, the universe is a different place of what it was previously and what it is now. And now electrons are able, they don't have charge because they don't have something to have charge against, like protons, because there's no protons. And then electrons form denser structures like quarks, my friends. They form, the universe was formed by 10 electrons, 10 photons, and those 10 photons are not enough. In this state, we have 10 electrons, 10 photons. 10 photons are not enough to form one electron, let's say. So the state of this is like 10 big, small balls are electrons, even the smaller balls are photons. And then if those photons and that state changes, for example, to 2 quarks, 1 electron, and 3 photons, and the universe has a different state. And then, as you know, quarks can bond together to form protons. Ooh. And the universe has a different state, is a different place when that happened. Right? And keeps going as current physics and chemistry tells us. Yeah, I think I gave you a good idea on how this works. Next time, I don't know, I'll talk about it. Um, yeah, I hope someone finds this and tries to understand what I'm trying to say. Bye. Thank you.